Hello everyone. So today in this video we are going to solve a question of LeetCode, that is count nodes equal to average of subtree. This is 2265th question on LeetCode and this comes under medium category. Alright, so let's start with the problem statement. Given the root of a binary tree, return the number of nodes where the value of node is equal to the average of values in its subtree. So basically in this question what we need to find is we need to find the number of nodes. Okay, we need to find the number of nodes where the value of the node is equal to the average of values in its subtree. So basically what we are doing here is we are first calculating the average of values of its subtree. So basically we are just calculating the average of values of its subtree and comparing it with the root node. Let's say if we are, let me take a pen here. Yeah, so let's say we are at this node right now. Okay, so when we are at 8, so the average of all the values of this subtree, let's say this is a subtree here, and the average of all the values is 9 divided by 3 because there are 3 values, so the average is 3 and the value of this node is 8, so it is not equal, so we cannot count this as a node. Let's see a possible answer here. So let's say if we select this node, so like if we see for this node, so the average of the values of this subtree, let's say this is a subtree here and this is the root node which we are checking right now. So the value like the average of all the values is 11 divided by 2, rounding of the values is equal to 5. Okay, and this 5 is equal to the root value, so we can count this as a possible count in the answer. All right, I hope this is fine. So let's see how can we approach the question. So to approach the question, what we need to do is, since we are starting from the bottom, because each subtree starts from the bottom, so what we can do here is we can use a DFS traversal here, because DFS is basically a depth versus traversal. So we will be using a DFS approach here, and what we are doing is, while traversing in the DFS, we will be storing two types of value. First, we need to store the sum of all the values. Okay, like if we start from the bottom, so first we will store the value of this, then we will store the value of this, then we will store the value of this subtree. All right. So what we need to do is we need to store the sum of all the values. So we will be making a pair. Okay, and in that pair we will be storing the sum and the count of number of nodes, because to find the average we need the sum divided by the count. Okay, so let's start the traversal. Okay, so the DFS traversal will start from the bottom and the leftmost side. So let's say the DFS starts from here. So when we are here, so the number of elements in this subtree, okay, this is a subtree, the number of element in this subtree is 1 and the average of all the values is 0. So we will be storing the sum first, and second one is the number of nodes. Okay, this we will be storing here. Now for this, the average of all the values, since it doesn't have any child nodes, so the sum of the average of all the values is 1 and the count is also 1. I hope this is clear to you. Now let's see for this node. For this node, the average of all the values is 8 plus 9 divided by 3, since there are 3 nodes in this subtree, so 9 divided by 3 is 3 and number of nodes is also 3. Okay, so we are basically storing the sum here, not the average. So the sum is 8 plus 1 is equal to 9. Why we are storing sum here? Because we can use this value for other upper nodes. Okay, if we store the average, then we cannot use that in the upper node. That's why we are using the sum here. Okay, so let's check for this node. For this node, the value of sum is 6 and number of nodes is 1. For this, the value of sum is 9, not 9, it's 11, and the number of nodes is 2. Similarly, for this, the value of sum is 9 plus 11 is 20, 20 plus 4 is 24, and number of nodes is 5. Okay, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. So can you see a pattern here? Because this pattern is very important in the recursive call. Okay, so what is a pattern here? Let's see. The pattern here is something like, let me use a green pen here. Yeah, so the pattern here is something like we are just adding the values of this first node. We are just adding the value of this plus this root node. Okay, so this will give us 24, and when we add the value of count, that is 3 plus 2 plus this one node, so it will give us 6. I hope you are able to understand the pattern here. So this pattern will help us to write the code for this DFS traversal. Okay, now let's see how can we count the number of node and return this answer. Okay, so let's see. Now when we find the average, so average is basically the sum of all the values divided by the number of values. Okay, so the sum is 24 and number of values is 6. So the average is 24 divided by 6 is 4. Okay, so this is they both are equal, so we can count this as a node, like as the desired node. Then for this, the average is 11 divided by 2, rounding off the values, it will give us 5. These both are equal, so we can count this as a node. Now for this, 6 divided by 1 is equal to 6. This is also true, we can count this as a node. Also we can count this as a node and this as a node, but this cannot be a node here. Okay, so let's count the number of nodes here. So this is one node, this is second node, this is third node, this is fourth node, and this is fifth node. So we will be returning 5 from here. I hope this is clear to you. If you still have any doubt in this approach, feel free to comment it down. I will try to explain it again. Okay, so let's quickly move on to the coding part. I hope this explanation is clear to you. Yeah, so what we are doing here is that first we are making a DFS traversal. So for DFS traversal, we will be making a pair of int comma int. This will be storing, first one will be storing the sum and second one will be storing the count. Okay, now let's name it helper function. Let's name it DFS and let's take pre-node from here. Okay, now let's see if root is equal to null. Okay, if root is equal to null, then we will be returning 0 comma 0 from here, because the sum is equal to 0 since there are no childs and there is no root, and the count is also equal to 0, so we will be returning 0 comma 0 for this pair. Okay, now let's see other condition. So let's take a pair of int comma int left is equal to, let's call DFS root left and store it here. Similarly, let's call for, this is basically a classic DFS which we do. Okay, so right is equal to DFS root right. Okay, now let's see the conditions which we are checking here. Okay, so let's take a integer sum. This will be storing the sum of the subtree. So int sum is equal to left dot first plus left plus second, oh sorry, for plus right dot first. Okay, so this is basically taking the sum of left subtree plus right part of the subtree plus the sum of the current node, so root value. I hope this sum statement is clear to you. So this is basically storing the sum of whole subtree. Now let's store a count here. So let's take int c is equal to left dot second. So basically this second part of this pair will contain the count. So left dot second plus right dot second plus 1. Okay, we will be counting the current node as 1. Alright, now let's check if the average. So average is basically the sum plus sum divided by count. So sum divided by count, let's round it off here, because like we have already seen 11 divided by 2, something like, we have just got it here. So we just need to round it off here. So round sum divided by c is equal to, if it is equal to the value of current node, so root value, if it is equal to root value, then increment the count from here. Let's initialize a variable which will be storing our count. This count is basically our answer which we need to return from this function. Okay, now let's return a pair from here. So let's return sum comma c. Okay, I hope this is clear to you. Let's call DFS function here and let's return count from here. I hope this should work fine. Let's just run it. Yeah, it's working fine. Let's just submit it. Yeah, it's perfectly fine. So let's calculate the time and space complexity of our solution. So the time complexity of our solution is big O of n, because we are traversing through all the n nodes, and space complexity is also big O of n, because the DFS approach also takes auxiliary space of big O of n. Alright, so I hope the solution in code is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. Thank you.